Hello Year 11, back again. What we're doing in this video is we're doing exercise 14F. It's called exact values of circular functions. Okay, so what this actually is exact values for sine, cos and tan of particular angles. Okay, we start to do this by using the unit circle. Okay, because the two angles we want to look at is 0 and pi on 2. So 0 is 0 degrees or 0 radian, doesn't matter which, 0 is just 0. Okay, now the angle 0 is from the origin to this coordinate here. This coordinate here is 1, 0. Okay, so the sine of 0 is 0. There is no vertical component here, so the sine of 0 is 0. Okay, the cosine of 0 is 1. It's the horizontal component. It's this value here. So cos of 0 is 1. And tan of 0, there's no vertical component. There's no green line here because we're going just straight across there. Tan of 0 is also 0. Okay, so something you just need to bear in mind. Okay, now we also want to look at the angle pi on 2, or 90 degrees. So 90 degrees is from here to here. Okay, now the sine of 90 degrees is that whole length there. It's all vertical components. So the sine of 90, or pi on 2, is 1. The cos of 90 is 0, because there's no vertical component. Okay, and the tan of 90 is actually undefined. Alright, because it's if you draw a line straight up, then it's parallel to the tangent line. Okay, so it's undefined, so we see UND for undefined, or UNDF I'll put for undefined. Okay, so they're ones you need to know. Sine of 0, cos of 0, tan of 0, sine of 90, or pi on 2, cos of pi on 2, tan of pi on 2. Okay, so looking at your unit circle, you should be able to very, very quickly work that out if you don't remember. Okay, here I've actually got a table of values. Okay, so 0 degrees is there, 0, 1, 0. Okay, sine, cos, tan, 0, 1, 0. That's what we just showed you. Okay, 90 degrees or pi on 2 is there. I'm going to refer to the radian values from now on. That's 1, 0 and undefined, as I just went through. Okay, but we've got these angles in between 0 and 90. We've got pi on 6, pi on 4, pi on 3. And you can see values in this table. Now these values you need to remember if you can, but if rote learning stuff like that is a bit tricky for you, then you can actually you can use what are known as standard triangles to construct these values. Okay, so there's two standard triangles you can use, alright, that you need to use. This first one here is a right angle triangle. Okay, it's a right angled isosceles triangle. Okay, we've got 90 degrees in the bottom corner here. We've got the two short sides of this triangle are 1 and 1, 1 unit, 1 unit. Okay, when you draw that, these two angles here are 45 degrees, or pi on 4. Okay, so that length is 1, that length is 1, that angle is 45, that angle is 45. Okay, and the side length of the hypotenuse is the square root of 2. Okay, or root 2. Just see it, c squared equals a squared plus b squared, c squared equals 1 squared plus 1 squared, c squared equals 2, which means c equals root 2. Okay? Now with that standard triangle that's just been drawn, or that we've got there, you can construct them yourself. Sine, cos, tan, SOHCAHTOA. We say, alright, well let's just use this angle here. What's sine of this angle? It's 1 over root 2. Sorry, that's cos. It's opposite over hypotenuse. Sine of this angle is 1 over root 2. Cos of this angle is also 1 over root 2. And tangent of this angle is 1 over 1. Okay, opposite over adjacent. So if we go to this line on our table here, pi on 4, we've got 1 over root 2 for sine, 1 over root 2 for cos, and 1 for tan. Okay? Another set of exact values that you need to be able to find that are very, very useful is for the angles of 30 degrees or pi on 6, and 60 degrees, or pi on 3. So I've got another standard triangle that's been drawn in here. Okay, some of this may not be super clear, but when you draw this, this is an equilateral. You draw an equilateral triangle, okay, and you can just sketch it. It doesn't have to be exact. I've done my best to try to make it as close as possible. Okay, so that's an equilateral triangle, but then I've cut it in half. I've just drawn a line from the apex up here down to there, so that that is a right angle. Okay, when you do that, this angle here in the corner, this corner, is 60 degrees, and this angle up here, because we've cut that 60 degrees in half, that's 30 degrees. Okay, now when you do that, oh, by the way, I said I should say, to make sure, when you draw this equilateral triangle, make the sides, the length of each of the sides of the equilateral triangle needs to be 2. Okay, so that when you cut this one in half, it's actually 1. Okay, so let's look at pi on 6. Let's look at this angle here. Okay, so this is 30 degrees. Now, the sine of 30 degrees is opposite over hypotenuse. Okay, so it's 1 over 2, it's a half. Okay, the cos of 30 degrees is adjacent over hypotenuse, that's root 3 over 2. And the tan of this one here is opposite over adjacent, 1 over root 3. Tan of pi on 6 is 1 over root 3, because this one is root 3. Okay, so that's where these three values come from. For pi on 3, we go down to this angle here. Okay, sine of this angle is root 3 on 2. Cos of this angle is 1 on 2. And tangent of this angle is root 3 on 1. So that's where these values come in here. Okay. Why is this root 3? That's what I've got here. Okay. This value here is root 3 because 2 squared equals 1 squared plus x squared. Let's say this one is x. 2 squared equals 1 squared plus x squared. So 4 equals 1 plus 3. So the square of this side is 3, which means the length of this side is root 3. For root 3 and root 2 in these cases, when you're using these ratios, do not approximate them. Do not approximate them, because the whole point of the exercise is to use exact values of circular functions. Okay, so these values are in the first quadrant, more or less. Okay, well, between 0 and 90 degrees, we've got half, root 3 on 2, 1 on root 3, but all the properties of symmetry of angles can actually be used to work out sine, cos, and tan of multiples of pi on 2, or multiples of pi on 3, or multiples of pi on 4, or multiples of pi on 6. Okay, depending on where you get positioned on the unit circle. Okay, but this is how it works, and this is how it goes. Okay, now you've got some worked examples there in the text to look at. Okay, and there's a few. It's a very short exercise, 14F, but get in and give it a go. Okay, see what you can do, and let your teacher know if you've got any questions. Thanks very much.